Hello, everybody. My name is Gautam, and I'm a grad student at the Khoury College of Computer Science in Boston. Today, I am excited to bring this introductory video about a novel system for achieving high fault tolerance with maximum resource utilization. The idea behind this project arose when I was learning about the traditional primary backup system in class. The typical system has a primary that performs all the heavy lifting, whereas the backups receive data from the primary and remain idle the rest of the time, right? As you can see, it's only when the primary fails that the secondary actually performs some sort of compute. But the downsides to this approach lie in plain sight. Out of the three machines, only the primary utilizes the full potential of its available compute resources. So, on average, two-thirds of the available compute resources are going to waste. Moreover, not only is this system highly inefficient in terms of monetary parameters, as well as with regards to time. The first and the most obvious question that arises is why? Why can't we just make better use of the available compute resources? Why can't a backup perform a primary task in addition to its backup duties? Here is where the key insight lies. And investigating this thought further, I discovered a very crucial figure. Operations involved in sending, receiving, and storing of backup data occupies a mere 4% of the CPU. What does this mean? 96% of the times, the CPU is idle in case of the backups. Why can't this idle time be used for something productive? Yes. Why can't a node in our distributed system serve as a primary as well as a backup at the very same time? The idea is simple, yet smart. If this process of backing up occupies a small fraction of the CPU, why not give the backup a primary job of its own? My architecture contains a coordinator, multiple workers, as many as we possibly want, and a client to perform this very task. Each job is run by a worker and backed up by multiple peers, which is a configurable number. As a result, the worker is always performing a primary task and is acting as a backup to multiple peers. Every node in the system is being utilized to its very full potential, and while and we still achieve a very high degree of fault tolerance. Let's say if a worker were to fail mid job, okay, let's say a worker 3 in this case, the coordinator would simply assign an available worker who was earlier backing up this particular job, that is worker 1 in this case. The worker would simply pick up the interrupted job from where it was last checkpointed or backed up, and that's it. The results, you ask? Well, they are quite terrific. I performed these evaluations of the Khoury Linux cluster, and let's start with the CPU utilization. It shot up from a mere 33% to 95%. Every single machine available to us was used to its maximum potential. Backup overhead, as I noted earlier, is a mere 4%. It's fairly low. It's a fairly low cost to pay for a high degree of fault tolerance. Time to completion of submitted tasks is three times higher, rather three times lower than what it would take if we were to perform these tasks serially rather than parallelly. On an average, 55 seconds is saved for each job that was interrupted mid-run. These are very promising results. This project is quite exciting, and I intend to keep working on this project. Uh, and for those of you who are interested and impressed by this system, please stay tuned for an in-depth video where I will go over the architecture and stack I've used, the machine learning tasks that the system is capable of performing, the evaluation graphs, the ones that I obtained by running the system on the Khoury Linux cluster. Yes, these are not theoretical numbers. I have actually run this, and I have actual data to back my system, and a demo. If that's what you want, please comment in the comment section. And I'll also discuss the further improvements and the possible applications of this system. And this brings me to the end. Thank you so much for watching. I am open to collaboration and discussing any ideas here. Feel free to contact me by mail. I'm available on LinkedIn, or the easiest way be would be to just leave a comment down below. Please do comment, share, and like if you enjoyed watching this video. Thank you so much.